In this part of the presentation, we focus on how license terms can be enforced once data has been downloaded from the Pistis marketplace. Offline enforcement is a critical component of the overall framework because once data leaves the control environment of the platform, users may modify it, repurpose it, or attempt to reintroduce it. Here we examine the techniques and architecture that ensure compliance even beyond the online boundaries of the system. The main challenge of offline enforcement is that previously downloaded data may be altered and then resubmitted back into the marketplace. A provider might modify or repackage data in subtle ways, and online monitoring alone cannot detect these changes. To maintain integrity, the system must identify near duplicates, partial reuse, and unauthorized duplication at the point of check-in. Without this capability, the marketplace becomes vulnerable to repeated uploads of modified or disguised datasets. The off-platform contact inspector is designed specifically to address these risks. It operates during the check-in phase before a dataset becomes available inside the marketplace again. Its purpose is to detect duplicated entries, assess whether data has been modified, and identify any near duplicate or partially reused content. By combining fingerprinting and similarity analysis, it prevents unintended duplication and ensures that data being reintroduced complies with licensing terms. This slide outlines the architecture behind the off-platform inspector. It shows how fingerprint extraction, similarity analysis, metadata storage, and communication components work together as part of the enforcement pipeline. This architecture enables the system to analyze new submissions in a structured, repeatable, and scalable way, ensuring robust protection against unauthorized dataset reuse. The inspection workflow follows a clear sequence of steps. A user first submits a dataset for check-in. The system extracts a fingerprint representing the dataset structure and content and stores it in MinIO. A pre-signed URL allows the similarity checker to retrieve this fingerprint and compare it with existing dataset fingerprints stored in the system. The similarity results are recorded in the data catalog, and finally, the system approves or rejects the dataset based on the level of similarity detected. This process ensures that no dataset re-enters the platform without validation. To support reliable matching, the system generates robust dataset fingerprints using multiple techniques. These include path value extraction for structured data, feature hashing to capture content characteristics, semantic embedding generated with models like SBERT and E5, and structural metadata. By combining these elements, the system creates a fingerprint capable of detecting both exact matches and more subtle modifications. The hybrid detection pipeline applies several layers of similarity analysis. The first layer compares structural paths and values. The second layer performs field-aware semantic and numerical analysis. The third uses embedding-based full document similarity to capture deeper meaning. And the fourth layer applies sliding window detection to identify partial reuse. The final similarity score is produced by combining all layers through a weighted fusion, offering a comprehensive and robust evaluation. The off-platform inspector provides several important benefits. It prevents unauthorized reingestion of previously downloaded data, detects near duplicates and partial modifications, and scales to support high marketplace volumes. It also produces explainable similarity reports that improve governance transparency. Most importantly, it complements on-platform inspection to deliver end-to-end enforcement, protecting intellectual property and strengthening trust within the data marketplace.